Hello students, I welcome you all to afternoon session. In this session, we are going to discuss about the unit 7 thermodynamics. It's a part of physical chemistry. So in this unit, we discuss about distinguish between system and surrounding, define closed, open and isolated system, then properties of system, intensive and extensive properties, thermodynamic process and types of process, reversible and irreversible, adiabatic, isothermal, isobaric, isochoric, cyclic process, state function and path function, internal energy, importance of internal energy, characteristic of internal energy. The term thermodynamics is derived from Greek. The thermo means heat and dynamic means flow. So thermodynamic means flow of heat from one place to another. In our daily life, we come across many useful reactions such as burning of fuel to produce heat energy and flow of electron through circuit to produce electrical energy, some metabolic reaction to produce the necessary energy for biological function and so on. So thermodynamics, the study of transformation of energy, explains such all process quantitatively and allow us to make useful predictions. Thermodynamics evolves macroscopic properties, that is heat and work, and their interrelations between heat and work. The principle of thermodynamics are based on three laws of thermodynamics: first law, second law and third law. The first two law, that is first law and second law, are the actual experience of interconversion of different forms of energy. The third law deals with the calculation of entropy and the unattainability of absolute zero Kelvin. So this law can be used to predict whether particular reaction is feasible or not. So the thermodynamics, in other words, deals with the equilibrium condition quantitatively but does not take any account the kinetic approach to the equilibrium. Next topic, system and surrounding. Before studying the law of thermodynamics and their application, it is important to understand the meaning of few terms are frequently used in thermodynamics process. So the first topic is system. So what is system? The universe is divided into two parts: system and surrounding. So universe is divided into two parts. What are they? System and surrounding. First, system. The system is a part of universe which is under thermodynamic consideration. System is a part of universe which is under thermodynamic consideration. It is separate from the rest of the universe. It is separated from the rest of the universe by real or imaginary boundary. So system, surroundings and boundary. The surrounding, the universe, surrounding and system. So the system is a part of universe which is under thermodynamic consideration. It is separate from rest of the universe by real or imaginary boundaries. Example, the system may be water in a beaker, a balloon filled with air, an aqueous solution of glucose, etc. is an example of system. And the basis of physical and chemical properties system, it can be classified into two types. So the system is called as a homogeneous if the physical state of all its constituents are the same. For example, mixture of gases are completely miscible, mixture of liquids, etc. So another one example, the water is mixed with milk. So the milk and water is completely miscible. So this is a homogeneous. The next one, a system is called as a heterogeneous if physical state all its constituents are not the same. For example, oil and water, the oil and water does not miscible. So it is a heterogeneous process. Okay. So the best example for heterogeneous, mixture of oil and water, it is a heterogeneous, and homogeneous, milk and water. Okay. Then next topic is surrounding. So surrounding, everything in the universe that is not the part of the system is called a surrounding. Everything is the universe that's not part of the system is called as a surrounding. The next one, boundary. Boundary means anything which is separate the system from its surrounding. Anything which separate system from its surrounding is called as a boundary. Okay. Then system. That's types of system. There are the three types of thermodynamic system depending on the nature of the boundary. So what are the three types of system? Open system, closed system and isolated system. Open system, closed system and isolated system. First we discuss about isolated system. Isolated system means a system which can exchange neither matter nor energy with its surrounding is called as a isolated system. What is isolated system? A system which can exchange neither matter nor energy with its surrounding is called as a isolated system. So here boundary is a seal and insulator. So example, hot water contained in a thermoflask. Hot water contained in a thermoflask is example for an isolated system. Hot water contained in a thermoflask, it is a best example for the isolated system. In this isolated system, both the energy, that is both energy means heat, and matter means a water vapor, neither enter nor leave the system. Okay, this is a isolated system. What is isolated system? A system which can exchange neither matter nor energy with its surrounding is called as a isolated system. Next, closed system. A system which can exchange only energy but not matter with its surrounding is called as a closed system. So, a system which can exchange only energy but not matter is called as a closed system. In above isolated system, which can exchange neither matter nor energy, but in closed system which can exchange only energy but not matter with its surrounding is called as a closed system. So here the boundary is an example. Here the boundary is a seal but not insulated. Hot water contained in a closed beaker is an example for a closed system. Hot water contained in a closed beaker. It is a best example for a closed system. In this system, energy heat is transferred to the surrounding but no matter water vapor can escape from this system. The next one, open system. A system which can exchange both matter and energy with its surrounding is called as a open system. Here exchange both matter and energy with its surrounding is called as a open system. Hot water contained in an open beaker is an example for open system. In this system, both matter, that is water vapor, and energy, that is heat, is transferred to the surrounding. All living things and chemical reactions are open system because they exchange matter and energy with this surrounding. So all the living things are a chemical reactions are open system because they exchange matter and energy with the surroundings. The next one, properties of the system. The properties of system, it can be classified into two, intensive and extensive properties. So some of the property of system depend on mass or size, whereas other property do not depend on mass or size. So based on this property, a system are grouped as extensive property and intensive property. So the properties are two, intensive and extensive. So first, what is extensive property? The extensive property means it depends on the mass or size of the system. It depends on the mass or size of the system is called as a extensive property. Example for extensive property, volume, number of moles, mass, internal energy, etc. Then definition of intensive property. Intensive property means it is independent of the mass or size of the system. So extensive is depend on the mass or size of the system. Intensive, it does not depend on mass and size of the system is called as a intensive property. Example for this, refractive index, surface tension, density, temperature, boiling point, freezing point, molar volume. It does not depend on any of them. So it is a best example for, these are the example for intensive properties. Then typical list for extensive and intensive properties. First, extensive property, it asks one mark questions. Some of them given are asked frequently, one mark questions. Volume, mass is dash properties. The molar volume dash, density, molar mass, it is a dash property. So extensive property, volume, mass of substance, that is mass of amount of substance, mole, energy, enthalpy, entropy, free energy, heat capacity. These are extensive property. Intensive property, molar volume, density, molar mass, molarity, mole fraction, molality, specific heat capacity. So it is a intrinsic property. Then next topic, thermodynamic process. So thermodynamic process, the method of operation which bring out about a change in the system is called thermodynamic process. What are they? Heating, cooling, expansion, compression, fusion, vaporization, etc. are some examples of thermodynamic properties. Some examples of a thermodynamic process. Types of process. A thermodynamic process can be carried out different ways under different conditions. The process can be classified as follows. First one is a reversible process. So the reversible process means the process in which system and surrounding can be restored to initial state from the final state without producing any change in the thermodynamic properties of the universe is called as a reversible process. So there are the two important conditions for the reversible process to occur. First, the process should occur infinitesimally slowly, and secondly, throughout the process, the system and surrounding must be in equilibrium with each other. Characteristic of internal energy U. The first point is the internal energy of a system is an extensive property. It depends on the amount of substance present in the system. So it is an extensive property. It depends on the amount of substance present in a system. If the amount is double, the internal energy is also double. So the internal energy of system is an extensive property. It depends only amount of substance present in a system. If the amount is double, the internal energy also is a double. Okay. Then second point, the internal energy of system is a state function. It's not a path function. It is a state function. We already discussed about what is state function and what is path function. What is state function? What is state function? The state functions thermodynamic property of system which a specific value given state does not depend on the path by which a particular state is reached. So internal energy of a system is a state function. It depends only upon the state variables. What are the state variables? Pressure, temperature, volume and number of moles. So T, temperature, pressure P, volume V and number of moles N of the system. The change in internal energy does not depend on the path by which final state is reached. The change in internal energy, it does not depend on the path by which the final state is reached. So the second point, the internal energy of system is a state function, depends only on the variables of the system. The change in internal energy does not depend by path by the final state is reached. Then third point is the change in internal energy of system is expressed as del nu equal to del nu equal to uf minus ui. So the change in internal energy means final to initial. So the U is represent energy. Del U is represent the change in internal energy equal to UF. UF is a final minus UI. UI is a initial. Final to initial. In a cyclic process, there is no internal change. Cyclic process, there is a internal change is a no internal energy change for a cyclic process. In a cyclic process, there is no internal change. So del U, there is a cyclic process, is equal to 0 because there is no changes there. So equal to 0. The next point, the internal energy of the system in the final state is represent UF is less than the internal energy of the system in its initial state, that is represent UI. So then del U would be negative. The internal energy of the system in the final state is represent UF is less than the internal energy of the system in its the final state UI, then del U would be negative. So del U equal to UF minus UI equal to negative. Okay. The next point, if the internal energy of the system in the final state UF is a greater than internal energy of the system in initial state, that del U would be positive. So simply say that del U, that is UF is a less than the final state is a less than the initial state, del U would be negative, whereas UF is a greater than UI, that is UF final state is a greater than the initial state, the del U would be positive. So del U would be positive. Okay. The next topic, heat. The heat is represent, the symbol of heat represent Q. The heat Q is regarded as energy is a transit occurs across the boundary separating a system from its surrounding. So heat change lead to temperature difference between system and surrounding. So heat is not a state function, it is a path function because it's flow from one place to another. So it is a path function, it's not a state function. So the heat Q is regard energy transit across the boundary separating system from its surrounding. The unit of heat, the SI unit of heat is joule, it represents J. The heat quantities are generally measured in calories. So represent CAL, calories. A calorie is defined as the quantity of heat required to raise temperature of 1 gram of water by 1 degree Celsius in the vicinity of 15 degree Celsius. Okay. Now, sign conversion of heat. The symbol of heat is what? Q. If heat flow into the system from surrounding, the energy of system is increases. Heat flow system from surrounding, the energy of the system is increases, so it taken to be a positive. So the Q is represent plus Q. Okay. If heat flow out of the system into surrounding, energy of the system is decreases, so hence is taken to be a negative, so it represents minus Q. Okay. The sign conversion of heat, the symbol of heat is Q. Heat flow into the system from surrounding, it should be positive. Heat flow out of the system into the surrounding, it should be negative. Okay. Then work. The work is represent W. Work is defined as the force multiplied by the displacement. You already studied in lower class. Work is multiplied by the displacement. So the force, work is defined as the force. The force is represent F is a multiply with the displacement. The displacement is represent X. So minus W equal to F into X. Okay. The negative sign, that is negative sign means minus, is introduced to indicate that the work has been done by the system. The negative sign should be indicate work has been done by the system by spending a part of its internal energy. So the work is a path function. It appears only at the boundary of the system. Okay. Then it appears during the change in the state of the system. Then fourth point, in thermodynamic surrounding is so large that macroscopic changes to surrounding do not happen. In thermodynamic process, surrounding is so large, so the macroscopic changes to surrounding do not happen. So what is the work? It's a path function, appears only boundary of the system, appears during change in the state of the system. It is a macroscopic, it is a surroundings is so large, so it macroscopic changes surrounding do not happen. What is the unit of work? The units of work is joule, that is J, which is defined work done by a force 1 Newton through a displacement 1 meter. So J equal to Nm. We often use kilojoules, that is Kj. For large quantity of work, 1 kilojoules equal to 1000 joules. 1 kilojoules equal to 1000 joules. The sign conversion of work. The symbol of work is W. If a work done by the system, note the point, the work is done by the system, the energy of the system decreases. Hence by conversion the work is taken to be negative minus W. Whereas in heat, by the system, the heat flow in the system from surrounding, energy of system increase. Out of the system, it is negative. Okay, here work is done by the system, the energy of the system decreases, the sign conversion is minus W. So work done on the system by the system means energy of the system decreases, so that it should be negative, so minus W. If work is done on the system, the energy of the system increases, hence by the conversion the work is taken to be a positive, so it represents plus W, plus W. Okay, this is a sign conversion of work. Then next topic, pressure volume work. Pressure, it represents P, volume V, pressure volume work. Okay. In elementary thermodynamics, only one type of work generally considered in the work done in expansion or compression of a gas. This is known as a pressure volume work or PV work, or another name expansion work. Okay. So the work involved in expansion and compression. Expansion, the meaning of expansion and compression. Okay. So expansion means is a enlarged. Compression means it is compressed. Okay. The work involved expansion and a compression process. Okay. In thermodynamic calculation, we are dealing the evolution of work involved in the expansion or compression of gases. The essential condition for expansion or compression of a system is that there should be difference between the external pressure and the internal pressure. Difference between the external pressure and the internal pressure. For understanding pressure volume work, let us consider one example. A cylinder. Let us take a cylinder which contains n mole of a ideal gas. Take a one cylinder, which the cylinder contains n mole of ideal gas, fitted with a frictional piston, of cross-sectional area A. The total volume of the gas inside, VI, and pressure of the gas inside P internal. If the external pressure P external is greater than the internal, the piston moves inward. Till the pressure inside becomes equal to P external. If the external pressure, that is P external, is greater than P internal, the piston moves inward. Till the pressure inside, it becomes equal to P external. So let us change. We achieve the single step and the final volume of F. So in this case, work is done on the system. Work is on the system means plus W. By the system means minus W. So work is on the system plus W. It can be calculated follows. W equal to F into del X. W equal to minus F into del X. Where dx is the distance moved. dx is the distance moved by the piston during the compression, and F is the force acting on a gas. Distance moved by the piston during the compression, and F is a force acting on a gas. So, the F equal to P external A. this is equation 7.3. Substitute 7.3 in 7.2. So equation 7.3 substitute in 7.2. 7.2 is W equal to minus F into del X. So we get A into del X equal to change in volume equal to final minus initial. So W equal to minus P external. What is the A? Del X. Change in volume Vf minus Vi. Now, so you put it a del X value Vf minus Vi. This is equation 7.4. So, W equal to minus external. So, final minus initial, we simply say minus del V. Del V. So, P external into del V. P external into del V. Since the work is done on the system, it is a positive quantity. In case its work is by the system, it is a negative quantity. But here the work is done on the system. So, note the point, the work is done on the system. It is a positive quantity. Okay. If the pressure is not constant but changes during the process, is always infinitely greater than pressure of the gas. So that stage the compression of the volume decreases. So the del V, in such case we calculate work done on the gas by the relations. By the relation W reversible equal to the limits of final to minus integrate of the final to initial P external dV. In the compression process Px, the external pressure is always greater than the internal, always greater than the pressure of the system. So that is P external equal to P internal plus dP. In an it is a compression process. Compression process, the external pressure is always greater than pressure of the system. So that P external equal to P internal plus dP. In an expansion process, the external pressure is always less than the pressure of the system. So the equation is P external equal to P internal minus dP. So compression process, the external pressure is greater than pressure. So the plus dP. In expansion process, the external pressure is always less than the pressure. So P internal minus dP. When pressure is not constant, the change is infinitely small step, the reversible condition. During compression from Vi to Vf, the graph will be platted pressure versus volume. Look like figure 7.4. Work done on the gas is represent the shaded area. The gas is represent shaded area. What done on the gas is represented by the shaded area. In general case, we can write P external equal to P internal plus or minus dP. Because the compression is a plus dP, the expansion is a minus dP. So, P internal plus or minus dP. Such process is called as a reversible process. Such process is called as a reversible process. For compression process, work can be related internal pressure of the system under the reversible condition by writing the equation. What is the equation? P W reversible equal to minus the integrate of limits Vf by P internal dV. For given system with an ideal gas, P internal V equal to nRT. P internal equal to nRT by V. So W, that is work reversible equal to minus the integrate of limit Vy, that is final to initial, nRT V dV. So W reversible, here the equation, W reversible to minus nRT integrate of final to initial dV by V, dV by nRT, because the nRT is come this side. So the nRT minus nRT, the integrate of final to initial dV by V. So W reversible equal to minus nRT. After the integrating, the integrating is a ln. So minus nRT ln V final to initial. So the ln, the value for the ln 2. That is a ln, the integrate ln, then 2.303. W reversible equal to minus 2.303 RT nRT log Vf by Vi. So Vf is greater than Vi expansion, the sign of work done by process are negative. The Vf is a Vi compression, the sign of the work done process is positive. Okay. Some of the summary of the sign conversion. Here the table listed here. If heat is absorbed by the system is represent plus Q. Heat is evolved by the system is represent minus Q. Work is done by the system minus W. work is done on the system is plus W. Okay, students, thank you. I send the link, watch the link carefully and do the assignment. Submit on correct time. Thank you, students.